All right, we're on lesson 2 of Unit 8. As promised, we are going to be multiplying a polynomial by a monomial. Let's jump in with a couple of examples and get her done. So, example 1 is going to be to simplify 2p times negative 4p squared plus 5p minus 5 times 2p squared plus 20. So if you're thinking, man, this looks like distributive property, well, that's because it's distributive property. Right now it's distributive property with variables stuck in it. So we solve it with distributive property. It's really that simple. So we're going to distribute this one, the 2p, into here and the negative 5 into here, right? Now, when we're distributing a variable, very often we're going to have to make sure we remember our exponent rules. When we have a like basis multiplied, we add those exponents up, right? So 2p times negative 4p squared, the coefficients, we just multiply, right? So 2 times negative 4 is negative 8. Positive times a negative is a negative, right? And then p times p squared is p cubed. Because if there's nothing there, there's an implied 1. 1 plus 2 is 3, right? So then we've got 2p times 5p. 2 times 5 is 10. P times p is p squared. Because p to the first, 1 plus 1 is 2. Negative 5 times 2p squared is negative 10p squared. Easy peasy. Negative 5 times 20 is negative 100. Now, all we have to do now is combine any like terms, and we're through simplifying. We've got p squareds to combine. Nothing else goes together. So we're going to bring down negative 8p cubed. And then 10p squared minus 10p squared, it cancels, goes away. Because that equals 0, right? So then we're just going to bring down minus 100. We're going to circle it and move on with our lives. Sound great? Yes, it does. Let's do one more. This one's going to look scary, but it's going to ultimately not be any harder than that one. So example number 2 is 2a times 5a minus 2, close parentheses, plus 3a times 2a plus 6, close parentheses, plus 8 equals, it's an equation, a times 4a plus 1, close parentheses, plus 2a times 6a minus 4, close parentheses, plus 50. How do you eat an elephant? One bite at a time. Same thing here. That's long and it looks crazy, right? But it's a bunch of simple stuff strung together, right? We can do the simple stuff. We know how to multiply. We know how to add exponents when like bases are multiplied, right? We know how to do all this stuff. So we're going to distribute this 2a in here, distribute the 3a in here, distribute the a in here, and distribute the 2a in there. Okay? So for this first one, 2a times 5a is 10a squared. 2a times negative 2 is negative 4a 4a. 3a times 2a is 6a squared. Bring down the plus 8. Don't forget that. Bring down the equals. I like to keep those lined up. Makes my problem nice and neat and organized. A times 4a is 5a squared. 1 times a is a. 2a times 6a is 12a squared. 2a times negative 4 is negative 8a. Make sure you bring down the plus 50. The biggest thing on a problem like this, the biggest trick is just keeping it organized, because the math is pretty easy. We can multiply 2 times 6. We can do that all day. That's no big deal, right? So now let's find our like terms on the left and our like terms on the right. So we're going to combine that with that. We're going to combine this one with that one, and this one with that one. And that looks like before we so we're doing a cleanup step. We're not moving across the equals yet. We're cleaning up, because it's always best to clean up the sides as much as you can before starting to move stuff around. It just makes your life easier. 10a squared plus 6a squared is 16a squared. We're going to bring down what we haven't touched. So minus 4a plus 8 equals 5a squared, excuse me, plus 12a. I did something wrong. What did I do wrong? Something happened. Something happened. Let's find it. There it is. A times 4a is, that's wrong. Found it. Found the mistake. How about 4a squared? 4a squared plus 12a squared is 16a squared. A minus a, 8a, is negative 7a plus 50. All right, let's get these a squared terms together. So we're going to subtract 16a squared from both sides, and wonder of wonders, they cancel out both sides. Happy days are here again. Negative 4a plus 8 equals negative 7a plus 50. Let's get the a's together. So we're going to add 7a to both sides. This one cancels, leaving us with 3a. Signs are different, so we subtract and keep the sign of the bigger one. Plus 8 equals 50. Let's get rid of this a. It's added, so we subtract a from both sides. 3a equals 42. And then we're going to divide 3 on both sides and end up with a equals 20. No. Yes. No. Yes. No. What did I do wrong? Timeout. Pause. Gonna find it. I'll be back. Give me a second. Maybe. It is too late, and I am old. So I forgot to distribute the 3a times the 6. I need to quit for the evening. This is the last video I do before I go to bed. So there should have been an 18a right in here. So I put it on there. I went ahead and left it. Let a tribute to mistakes happen and all of those things. So then 18a minus 4a would be 14a. Signs are different. We subtract, keep the sign of the bigger one. And then when we add 7a to 14a, it's 21a. And so we divide off the 21 on both 21 on both sides. Those cancel. 42 divided by 21 is in fact 2. So that's it. I will see you in the next one after I have rested and am awake and ready to make less catastrophic failures and whatever else, where we multiply a polynomial times another polynomial. It's going to be great. You're going to love it. I can't wait to see you in class if you're one of my students. If you're not, thanks for joining us. Check out emberlearninglabs.com for more of what we're doing. Bye-bye.